Guys, BBI here. I want to stop and say thanks for tuning in and checking out whatever the video is about that's about ready to come up next. If you could take a minute and hit subscribe, I'd greatly appreciate it. And if you enjoy what you've seen here, make sure to hit the like button. We'd greatly appreciate your support. Anyhow, guys, all that aside, let's get on with the show. Well, shit. Just by pure coincidence. Oh, ow. Come on. Oh. Oh, let's see. Got another black cat. Let's see. Got another fat cat. Pardon me. I keep calling these black cats because the cat's black. It's a fat cat. Independent voltage controls, huh? Final and driver. Runs off 110. Okay. Sure got a fat schmariot of lights. We've got light, light, switch, light, light. I got no notes. Well, it's absurdly late in the middle of the night, so it's surprising I wasn't able to reach him. So this is a 2x6, because that's what it says down here. 2x6. Let's see what we got. Two by 8. I'm sitting there counting transistors and going, what the heck? All right, so oh God, menagerie of death in here. Okay. No, I think that's my guy. All right, so I took a couple minutes and looked at this while I was on the phone with Mr. R. Mr. R says he took this thing and he's been running it, and it's got 10 transistors in it. And we all know that an 8-pill device takes 200 amps worth of power supply to run safely. Okay, 200 amps worth of power supply to run safely. This has 10 transistors in it, which is about 225 to 230 amps worth of power supply. We have 1, 2, 3, 4, 5. 5 35 amp switchers in here, which is 175 amps worth of power supply. So we're asking these power supplies to do like 115 to 120% output all the time. And if they can't, they start to drop voltage. The fact that it's on a 110 outlet really does not help the situation none whatsoever. This amplifier deviates greatly from the other amplifier that was here. It's got completely full of Alibaba caps. Completely full. The 120s, they're all Alibaba caps. The input and output tunes are all Alibaba caps. He's running a 4-port combiner, a 4-port splitter and a 4-port combiner. He's got his capacitance in the wrong spot on the Pi-L network on the output. So this puts me in a hard place. It's like I was telling Mr. R on the phone that we can't do this. There's not enough room inside this cabinet with the way this thing is currently laid out. I have to figure out a place to stick another switcher in here just to make it so we can run this thing as a straight 8. There's not enough current inside of this cabinet to do the job. So I'm sitting here looking. And if I'm really super smart about it, I can take and I can slide all of these power supplies forward. So my idea now is I can take and I can slide these supplies forward. Then I got to open this one up, go inside, modify it like one of these units, and then bring it into chain with the rest of these so the variable knobs will work on the front. Freaking knobs all slopping around. Then that'll give us enough to run the 8-pill section safely. If we leave the 2-pill section in here as a driver, we're going to be about 10 amps short, theoretically. Now we all accept the fact that these are universally about 35 amps apiece. That's max chooch. Max output 35 amps. So I like to run these at about 25 amp, 30 amp. In the beginning I used to use these a lot, and I had 2 or 3 failures where I didn't understand that you couldn't put 40 amps on the 30 amp supply. It just wouldn't last. It just don't last. So then I had to embrace the fact that, okay, somebody wants a 200 amp supply, we're going to put like 3 or 4 extras in there and then the thing will stick together. It is what it is. It is what it is. Now with the Chinese import tariff, these went from about $19 a piece to $25, $30 a piece. And you can't just call up and get like 100 of them anymore. You can only find like 4 or 5 at a time on eBay. So, make a long story short, we're going to have to disassemble about 60% of this box. So I'm going to quit bitching about it, and I'm going to embrace it. We got 2 pop pills, completely burned up output section. I don't know what we got going on for transistors in here, and we're going to look at all the caps on the amp side, but our primary holdup and our primary issue is our power supply. There's just no way around it. None whatsoever. All right, let's start here. So where we left off is I was doing the math and trying to explain to you guys some things, and then I really started to look at this amp, and it dawned on me that this unit has got 2 knobs on the front of it here. So we got the driver voltage over here, and then we have final voltage over here. And that made me look. This end power supply is completely committed to running just this 2-pill section. And then the other thing that dawned on me is either 30 amp switchers. These aren't 35s. There's no such thing as a 35. It's like 35 amps max. So these are 30 amp switchers. 1, 2, 3, 4. Okay? There's 120 amps worth of supply feeding 8 transistors. So I got on the phone with the customer and I said, look, I hate to do this to you, but there's not enough physical real estate inside this cabinet to stick enough switchers to make this work. I think we could reconfigure completely how these are in here, and maybe get one more of these in here, but we've got to get at least one. So let me show you my logic. Let's go back over here to the confuser. Let me zoom in here a little bit for you guys, for your viewing pleasure. Okay, so right now, we've got 4 30 amp switchers. It's 120 amps, right? So if we get rid of the driver section completely, bypass it, and we use the transistors out of there to repair the amp, 1, it saves the customer money, but 2, it's going to create a much more stable amplifier. Okay, so then we're going to add an additional 30. That gets us to 150. That's just by using the power supply that he's got committed right now for the moment for the driver section. So now if I add an additional 30 amp supply, that gets us to 180, which is a whole lot closer to about the 200 limit that we need to be. I mean, ultimately, ideally, if we had the space, we we would put one more switcher in there total, okay? So then we could get ourselves 210 and we'd be safe. But I feel that the transistors will last a whole lot longer if they have the proper number, or even closer to the proper number of switchers in there. But 4 30 amp switchers, no, absolutely not. And the more and more I end up looking at this thing, the more it doesn't make any sense to me. There's a bunch of little shit that's going on. Like over here at the relay, there's some stuff going on. I don't quite understand that, and this preamp relay is about ready to fall off. It's not that I don't understand. I understand what he did. I don't know why he would do it this way, though. It doesn't make any sense. And then the same thing as in the last video, we got to make sure that we're using the right thermal compound. So I might end up having to rip all the transistors out of this thing again. But we've obviously got some blown 10 ohmers, and then our combiner ring. You guys look, you can go and put 500 watt resistors back here, and they're still going to heat up, break down, and burn up if you end up having transistors go down and there's imbalance. It's just the way it is. So this protects the transistors. Having these larger resistors protects the rest of the transistors, but it can't mask any imbalance. Now, once again, it's semi-decent solder work that's up in here, but this over here, them 4 modules to power all of those transistors, epic fail. So we're going to try and shoot for the best that we can, and it's like I told the customer, you're going to have to back your drive down quite a bit. He said, man, it'd run and run and run and run and run, and then it'd always fail in the same sections over here. Always, every time. And I said, okay. Now, what I take from that is that for some reason, this particular section is getting slightly less current than whatever over here. So it's the reason the pills keep going down in the same spot. That, and it's in the middle. And where's going to be the most heat saturation on this board? In the middle. But the pills have been starving to death. I mean, absolutely starving to death. There's no way 4 30 amp switchers can power 8 transistors. It's not happening. Okay, so now I'm going to start the process of the power supplies first. Now there's about 3 or 4 different ways you can do the voltage control mod on these. Okay, so I've got to pull one of these out completely. I've got to open this one up, and then I got to see how he's got the voltage mod done on the inside, which is totally cool. And then we're going to copy it and link it into the system. And we're going to take and slide all 5 of these power supplies forward just by about an inch or so to make enough room to safely slide this one in back here in a bag. Yay. Okay, let's get her done. Enough talky, more do. Well, he took the data sticker. Let's break the seal on this here with our thumbnail. He took the data sticker off the outside of the power supply. It's pretty easy mod he's got going on here. He's controlling ground connection, I do believe, for his voltage supply. And he's doing it up here. Most of us do it back here by modifying a resistor back here, but we remove one resistor back there and then we take 2 leagues off, and never mind. So we'll go ahead and we'll do it this way so everything matches. He's got the same mod going on every one of these. All right, so this is our data tagged 360 watt, blah, 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 30 amp. So it's the same unit, exactly the same unit. So, oh man, only the best from China. Exact same unit, same board. Actually, this is a 360 and this one's got DC 400, so this is 400 more watts, supposedly. It's the same board, same parts, same caps, same transistors, same. So, needless to say, we had only 4 30 amp modules powering 8 transistors. Okay, well, Okay, I think I'm done. I got all the little twitchy bugs out of this thing. Got it to settle down and run fairly well for what it is. Too small of output transformers, so the cores are reaching the edge of saturation. Let's start at the beginning. Like I addressed initially in the very first segment of the video, you cannot run an 8-pill on 4 power supplies. It's too much current draw, and you'll end up eventually popping the power supplies, or you're going to murder the transistors. So we went ahead and we dropped the 2-pill section out, the driver section. We bypassed it so we could salvage most of the box. Otherwise, this thing would have never worked. We could have, well, with 3 supplies, we could have maybe run the 4-pill. Well, 4 supplies, we could have run it as a 2x4. And with the 5th supply, maybe a 2x6, maybe. But not with enough substantial amperage headroom that I'd feel comfortable attaching my name to this in any way. So we went ahead and, as you've seen me clumsily do, I had to slide all these power supplies forward, except for this one. There's a switch here that operates the preamp in standby and operate mode. I had to slide this one back just a hair. We we're able to safely mount an extra 30 amp module in here, so that now we have a total of 180 amps worth of supply. I was able to do his kind of Quasimodo voltage regulator mod that he's got in here in this particular unit. We had to come up with a different way of distributing the power, since the design only allows us to have 3 points of current distribution, but we can achieve this by having the shorter legs, and it's working quite well. The amp, all in all, its overall construction, I can see the different steps of growth in his ability to put things together compared to the last 3 that I've worked on. It's my job to fix the amps, not my job to sit here and talk crap about anybody. I'm just pointing out what I had to do to get this thing to work properly. Going in, just sitting here and looking at it, and I have built several of these myself with these particular transistors, I knew what we had to do to get the thing to go and go stably and run for a while. So we dropped the 2-pill driver section. We bypassed the voltage control over here on the front for the 2-pill section. So this is now dead. It does nothing, which is good. So we went ahead and daisy chained the voltage control for this particular unit over here to our primary voltage control, which is here, which is nothing more than a few K potentiometer with a reference to ground. And then we started playing with this section over here. We keep having 2 of the same transistors blow, from what I understand, in these 2 center sections, which is where you're going to get your most heat saturation. But if you got to also think, it's also directly in line with your driver section. But of course, with not having enough power supply inside this amp by design in the original builder, I bet you on your modulation peaks we were seeing close to maybe 10 volts on the transistors, which is going to cause a lot of extra heating. So after recognizing that we had the power supply issue, I started looking at all of our capacitors. I did have to change out quite a few components. He had 180 puff on the input, 180 puff on the input capacitance, but he also had 181, 188, and 184, and 182 on the output section. So he had his capacitance on the input and the output the same. I've never found that to be a stable environment. If somebody gets their coax links not just right, you're going to end up having an oscillation issue, and the amp's going to run away and it's going to end up popping pills. So I went ahead and we brought this down to 120 puff, which is something that we've had to come up with since the design of the HG2879 is a continuously evolving monster. And then we took each one of the output sections, we went with metal clads. We are now sitting at 150. The output tuning circuit for this box was wildly out of play. It had this little job coming off the 4-pill combiner, and then a big long lead of wire that went all the way over here, open air, over to the relay. And then we had the capacitance in the middle of the Pi-L circuit, which we never do, ever, never do. Once again, it adds to second and third order harmonics, which show up as great on the watt meter, but then it looks horrible on the spectrum analyzer because the power is so scattered because of the capacitance. The impedance bump causes a false representation of output power. So we removed that, and I initially started out with a long piece of wire. I just wanted to see how it would run. It has been a long time since I have built one with the combiner setting this far from the relay stage. I had to dig way into my bag of tricks, and I sat here and I thought about it. So I went ahead and I did a new output induction coil, which turned out to be about a turn and a half, maybe a turn, okay? But then we're running that through some RG400, and then we're hitting this with about 180 puff here at this tuner point. By dropping all the extra induction and going to a balanced 50 ohm circuit, it's going to lead to a much more stable environment for the amplifier to work within. The turns ratio on the combiners and the splitters were correct. All the coax links were exactly the same. I went through, as you've seen in the previous segments, and I checked all of these little blue capacitors down here. They are all 119 or 118.5. So they're within one puff, 1 picofarad of each other, which is good. That's within 1%. This is a 100 puff doorknob with an 85 puff variable capacitance tuning tube, which we have soldered in the vertical position. We took the, look at that. Look at this little guy. Look at this. The longer I look at this, the more shit I find this off. Okay, so we cannot take, there's no pin nut here. We cannot take a machine screw. We cannot take a machine screw to hold this cabinet in place. And since this is our primary support, once again, something else that I found that I need to redo. So let's take a minute and we'll unscrew this. Grab 2 sheet metal screws so we can get at least a decent mechanical connection going on the board. Needless to say, this turned out well. Now fully loaded out, this amplifier, the voltage internally on the transistors, no matter where you meter it from, does not drop more than about maybe 1/10 of a volt, which is what we're shooting for. Okay, oh no, look, I got one more turd sickle here. Sorry guys, I've spent way too much time on this amp. I thought that this would be a lot quicker than what it was, and it has turned out to be a lot of, oh look, now I've got to completely rewire this. Oh look, once again, something else I've got to change. It's been frustrating, but at the end of the day, it's done. It's done properly, and I'm pretty sure that this guy's going to go on and be able to have good use with this amp, as long as he doesn't overdrive it. He keeps it in a good, cool environment, and he feeds it with enough 110 voltage. That's all that counts. I got a lot of pressure on me these days, guys, to get stuff done. I've got people screaming at me, and I'm like, dude, I will gladly send you back your stuff. I refuse to sacrifice quality for quantity. I refuse to do it. And it's not going to happen today, tomorrow, or next week. So with all this being said, let me take this big heavy camcorder off this tripod and let's run this son of a bitch. I think you're going to appreciate it. I'm going to start over here for a reason. I spent a good portion of this last week working on updating my workbench. When I initially put this whole thing together, it was just kind of, I started adding radios as I went. I was adding coaxes and I was adding radios and I was adding bird meters. And in this last video that you guys watched, you've seen that I had a loose coax connector. Well, come to find out it wasn't a loose coax connector, it was a bad coax end. And that's what was causing the input SWR to jump up randomly. Well, I can't have that. So instead of just replacing the end, which would have made the coax electrically too short for resonance, I went ahead and I replaced everything with RG400DS. Every single jumper from every single radio to all the bird meters is now primarily RG400, or pardon me, RG316DS. Everything is cut and tuned with zero reactance to the coax now, which it was before. This is just new. These are all through soldered ends. I should probably get another 3 or 4 or 5 good years on the workbench before I have to come back and revisit it. So this is now the product of that. So let's start over here. Let me turn this off, flick this to standby. So we've got our 1,000 watt slug in peak, 1,000 in average, and 5 watt slug back from the Bird 10,000 watt dummy load, as we always do. Hello. Here's our whole whopping 20 watts of drive. Hello, audio. That we've all come very accustomed to seeing. Check this out. Hello, audio 1, 2. Okay. That is centered at 26 megahertz, top is 52.1. Bottom is 0. Engage the warp drive. Preamp, operate, standby. Okay. Hello, audio. That's with 20 watts of drive, you guys. Hello, audio. We're pegging the crap out of the 1,000 watt scale. Hello, 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 hello. Hello, audio, 1, 2, 1, 2, 1, 2, 1, 2. That's a half a watt falling back to a quarter watt. Hello, 1, 2, 1, 2, 1, 2. Beautiful. Our voltage. Hello, 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 hello. Hello, audio. We're doing about 11, maybe 1,200 peak watts with 20 watts of drive. So take it on up to the 2X. Now you guys remember how this reads. Right here is the 1,000 watt scale right there. So 12, 14, 16, so on and so on. Hello, audio. About 1,200 watts worth of drive, or 1,200 watts of power. So let's continue on. Let me go over here. I'm going to disconnect the 2950 here real quick. And we're going to hook up the striker. Let's go ahead and shut that down, turn this on. So put this in standby. Hello, 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 hello. Sorry. Hello, audio. Hello, audio. What am I missing? Hello, audio. Hello, audio. Hello, audio. All right, let's go back on up to the 2X scale. Hello, audio. That's 1,600 watts of power with a striker hitting it. Hello, 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 hello. Now watch that input needle. Hello, audio. Hello, audio. Hello, audio. Hello, audio. So now, 90 watts of drive. Okay. Gets 1,600 watts of power. Let's continue forward. So let's see, the next thing I need is the blue coax. I had to come up with a color code system because before all the coaxes were different colors and I could grab them without even having to think. So let's put this in standby again and off actually. Let's turn off the 955. Let's go over here, let's turn on the striker. Hello, audio. Let's go back down to 1X. Hello, audio. Hello, audio. About 160. Let's look at the spectrum analyzer. Hello, audio. Okay, now this radio is a little bit dirtier than the other two. That's fine, I'm comfortable with that. It's all within frequency. So we know this going in. Hello, audio 1, 2. Okay. Let's go ahead and let's turn this on. Hello. 2X position. Sorry, guys. We were in 1X. Hello, audio. Hello, audio. Nice, easy 1900, almost 2000 watts if I hoop in it. Hello. Voltage on the front of the amplifier. Hello. 1/10 of a volt drop. Hello. 11111. That's the radio. It's not the amplifier. Input tune. Let's see. 490s right here. Hello. Audio 1, 2. This amp is electrically correct. All we had to do is change out about 50% of the parts and add another power supply to it and delete 2 transistors. The voltage regulator is fully functional. Let me show that as well. Now I have no knowledge of what this thing did before it came here for power. I don't know. I'm sure it'll do much more if we drive it harder. Like if you put maybe a 2-pill 2290 into it, I'm not going to concern myself with it. I know for a fact this thing is working electrically perfectly. So there's one last thing I got to do. Now the last thing I want to actually do physically to this box is I want to hook it up and run it with the lid on it. And I want to see what the fans do. That's the last thing I've got to check. Short of doing a complete overhaul of this box and replacing the output transformers. Because as we can see, as we start to go up in drive, and if we look at it on the oscilloscope, we can also see the transformer cores, because of their size. Once again, one of the limiting factors why we don't use these primarily in a lot of builds anymore is because they're reaching their saturation point. They cannot field flux anymore and they cannot absorb any more RF. So the cores start to reach their max saturation and they start to heat. So I'm sure we'll be able to get 2300 out of this in the customer's end. I'm not going to go there today. So let me throw the lid on this thing and we'll go from there. Okay, so I have the power supply hooked up to the old 2-pill section down in here, which I had to bring positive power to when we abandoned it to link the power supplies with the rest of the amplifier. And what do I mean by that? I had to bring positive current to it, or otherwise none of this preamp stuff worked in the front. It's apparently linked off of that one supply. So we've got the 490 in play now. I'm going to drive it up. Hello, audio. Hello, audio. Hello, audio. I'm done. Fans aren't backing down, they're not slowing down, they're not wibble wobbling, there's nothing. Which means no RF is getting into the fan bodies, and they're moving enough air. That's it. I'm done. Another fat cat in a bag. I've got a mountain of X-Forces, a mountain of, oh man, I got a lot of donkey stumpers here recently. But I pretty much closed the door. I'm not letting anything more come in at all, you guys. Nothing. At all. Nothing. I cannot stress that enough. I've got to make room. I want to get my shop back. Now what is on the schedule and the docket for next? I've got a 20 pill that I'm going to start this week turning into a 24 pill. I got a 2x6 that I need to repair. But I've got to do these SBs. I've probably got 30 SB220s in here that I need to sit down and do for the next week or so. So I'm going to start on this 24 pill rebuild. And the base of it's going to come from an old raggedy 20 pill. But publicly you're going to see a bunch of SB220 videos come up here for the next little week or so, week and a half. So I hope you guys are ready for that. Gentlemen, I've lost my enthusiasm for this day. It's Monday, and Mondays are always the hardest for me. The phone rings quite an awful little bit. I'm going to put the tins on this, and I'm going to put this in the confuser, and my ass is going to bed. I appreciate you all tuning in. On to the next Bajeo, the next project, the next... I'll see you on the next one, guys. I appreciate you all checking out what I had to say today. I'll see ya.